Today we're going to continue with section 4.1, which is exponential functions. Today we're just going to focus on graphing exponential functions. So let's take a look at this example. It says we want to graph f of x equals 3 to the power of x and g of x equals 3 to the x minus 2 power minus 1. So we're going to graph two graphs on the same one. And then we're going to state the horizontal asymptote, domain, and range for both of the functions. So remember when we started talking about this yesterday, I'm going to make a table of values. So I've got my f of x function where, remember, I can put any number for my x. So I'm going to go -2, -1, 0, 1, and 2. So those are the numbers that I'm going to do. So we'll have 3 to the negative second power, 3 to the negative first power, 3 to the power of 0, 3 to the first, and 3 squared. So 3 to the negative second power is going to be 1/9. We've got then 1/3. We got 1, 3, and 9. All right, so I'm going to plot those points. So -2 1/9, that means it's going to be super, super close to 0. We've got -1 1/3, so a tiny bit higher. 0, 1, 1, 3, and 2, 9. All right, so notice that there's a curve to it. Notice that we'll be getting closer and closer and closer to the x-axis on the left side, and we're going to be getting higher and higher and bigger as we move to the right. So as far as then stating what the horizontal asymptote is, remember in this case, if it's never going to touch the x-axis, that means that y equals 0. And if you want, you could even, draw it in. So, I mean, it's kind of hard to see because it's on the x-axis, but there's my horizontal asymptote. I actually would prefer that you draw it in. So go ahead and draw that in. All right, if we want to state the domain, remember we didn't have to, we could plug in any number for my table. So it's always going to be that my domain goes from -infinity to +infinity. And as far as my range is concerned, I am never going to have any negative numbers for my y's. And the first number is going to be 0, but it's not including it. So there's a parenthesis. But all of the other y's that are positive, it just keeps going and going and going. So 0 to infinity. So there's my first function. Okay, I'm going to change colors. And now I'm going to be looking at the g of x function, which is 3 to the x minus second power minus 1. So because we already have that original function, notice how the base is the same. So the only thing that's different with the f of x and the g of x is that g of x has some transformations. So if we can identify those transformations, we don't really even have to build another table. We can literally just use the ordered pairs that I got from the f of x function, and we can move things over. So notice that because we have x minus 2, we do have a horizontal shift that's happening. And remember, we always want to go in the opposite direction. So because it says -2, we want to move 2 to the right. And because we have a number that is not connected to that base, it is outside of the exponent. That means that that is a vertical shift, and we do keep the sign. So because it's a -1, that means we want to move 1 down. So literally, we can just take each of our ordered pairs from this f of x function, and we can move 2 to the right and 1 down. So we've got -2 1/9. I'm going to move 2 to the right to take me to 0, and then 1 down means that we're going to be at -1/9. Okay, so from -1 1/3, I can move 2 to the right and then 1 down. At 0, 1, we can move 2 to the right and 1 down. At 1, 3, we move 2 to the right and 1 down. And then from, did I mess up on that? Okay, and then from 2, 9, we can move 2 to the right and 1 down. Okay, notice that also then my horizontal asymptote is going to shift. And so it's going to shift whatever we moved vertically. So because we moved down 1, that means that my horizontal asymptote is going to move down 1. So notice that here is my new graph. And you know what I should be doing, so I know which one is which, I should also be labeling these things on my graph. So we've got my f of x function, we've got my g of x function. Okay, so the shape itself never changed because we didn't have any kind of reflection. It just shifted 2 to the right and 1 down. So going back to identifying all the key pieces, my horizontal asymptote ended up being now y equals -1. So essentially, hopefully we notice that the number that I got for my horizontal asymptote is actually what that vertical shift is. So notice with my f of x function, because there was nothing being added or subtracted from that 3 to the power of x, that's why y equaled 0. Okay, so essentially whatever is shifting up or down becomes then that horizontal asymptote. So there's that relationship there. Domain is not going to change. It's going to go from negative infinity to positive infinity. But now my range has changed because now I do have some negative numbers in my range. But once again, what's the lowest number? Well, it was getting closer and closer and closer, but not actually touching -1. So here we're going to start at -1 with a parenthesis, and then we're still heading up towards positive infinity. So there are my two graphs labeled. I've got my horizontal asymptotes drawn in my graph as well. And then I've identified the 3 pieces that they asked for. All right, so let's do another one. We've got f of x equals 3 to the power of x. So notice how that one is just like what we did in the last example. So we can start there again. I know that if it's 3 to the power of x, we're thinking our table going from -2 up to +2, where 3 to the -2nd power is going to be 1/9, 3 to the -1st power is 1/3, 3 to the power of 0 is going to be 1, 3 to the 1st power is 3, and 3 squared is 9. Once again, notice that because there is no shifts involved, as far as our horizontal asymptote goes, we're going to want y to equal 0. So if I have my horizontal asymptote drawn in, I can plot my points. So we've got -2 1/9, -1 1/3, 0 1, 1 3, 2 9. I'll label it f of x. Notice that once again, our domain will always be the same, going from -infinity to positive infinity. And then because our range doesn't touch 0, but it's everything positive, we can say 0 with parentheses up to positive infinity. Okay, so essentially the exact same thing that we had in our last problem pertains to this. Okay, so now we want to talk about then our g of x. There's a lot more going on in this one. We've got -1/3 times 3 to the x plus 1. All right, so this time, because there's a lot more than just horizontal and vertical shifts potentially here, notice how there's a negative out in front, so that means we have a reflection. There's also a number out in front, which means that we're dealing with either vertical or stretching or shrinking. So this one, I don't know about you, but for me, I think I just want to play it safe. I'm going to make a table kind of like what we did in the past, where I already have my basic table here. Okay, so remember then that was where, here, let me fix this table really quick. So if we think about how we did it in the past, we had it where, okay, remember these were my x's, this was my f of x. So now if I continue to build off that table, remember I want to always deal with any type of multiplication or division first, and then I'll deal with addition and subtraction. So the fact that we've got this negative 1/3 being multiplied by 3 to the power of x plus 1, remember, because that negative 1/3 is outside of that base, that means that that's dealing with the f of x column. So I know that I want negative 1/3 to be multiplied by the f of x column. Okay, so all of those numbers, so 1/9 needs to get multiplied by negative 1/3. We multiply fractions straight across, that's negative 1/27. 1/3 times negative 1/3 is going to give us negative 1/9. We've got 1 times negative 1/3, so that's going to give me negative 1/3. 3 times negative 1/3 is going to be negative 1. 9 times negative 1/3 is going to give me negative 3. Okay, notice that we have a number connected to the exponents. So that means that we are dealing with a horizontal shift, which means that that is going to be dealing with the x column. And that means that we want the opposite. So instead of adding 1 onto the x's from that very first column, I actually want to subtract 1. So negative 2 minus 1 would be negative 3. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. 2 minus 1 is 1. So then essentially, we have to understand that our ordered pair always goes x first and then y. So our ordered pair is really negative 3, negative 1/27, negative 2, negative 1/9, negative 1, negative 1/3, 0, negative 1, and then 1, negative 3. Okay, notice that I don't have anything that was outside being added or subtracted, which means that there is no vertical shifting happening, which means that as far as identifying our horizontal asymptote for this g of x function, it's still the same. It's going to be y equals 0. So that doesn't change. It's just the fact that we have a reflection as well as a horizontal shift. Okay, so we'll start at negative 3, and then obviously we've got negative 1/27, so that means we're below the horizontal shift here, and once again, it's going to be super, 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 super close to 0. Okay, then we've got negative 2, negative 1/9, which once again is below, super close to 0. Negative 1, negative 1/3, still close to 0. 0, negative 1, and then 1, negative 3. Okay, so notice that this time when I connect my points, all of my y values were negative, which is why we are below the x-axis. So, oops. Once again, the domain doesn't change. We could go from negative infinity to positive infinity, but this time notice that my range is going to be different because none of my y values are positive, which means that because I'm going down to the right, I'm hitting more and more negative numbers. So my range is going to start with negative infinity, and it's getting closer and closer and closer to 0 without actually touching or crossing the x-axis. So this time it goes from negative infinity to 0. Okay, so I would like you guys now to pause the video and try this checkpoint problem. So you're graphing two graphs. We've got f of x equals 3 to the power of x again, but then now we have g of x equals 3 to the x plus 3 power, and then plus 2. Once again, state the horizontal asymptote, domain, and range for both functions. All right, so hopefully you didn't really maybe have to make the table. You could if you wanted to. It was just dealing with horizontal and vertical shifts, so that might be a little bit easier just using the ordered pairs. But if there was any types of reflections or any type of stretching and shrinking, I would definitely encourage that you use this table. Hopefully these are the answers that you got. Notice that with the g of x function, we're dealing with a vertical shift of 2. So that's why y equals 2 is that horizontal asymptote. Yeah, so hopefully your answer matches mine. Okay, so that's us getting more in depth with graphing exponential functions. Make sure that you are reading the directions for the homework very carefully. Make sure you're labeling your graphs, the two graphs in each, and make sure that you're drawing your horizontal asymptotes as well.